Okay, it's 2 o'clock p.m. Eastern, 11 o'clock a.m. Pacific time. Good morning, good afternoon, good evening to wherever you are that may be calling in. My name is Joe Dobbins, and I'm your host for our AU11 2021 WebEx Series. Today, our topic is electromagnetic safety issues. Why so controversial? This topic will be presented by Dr. C.K. Chow, he's PhD with the Technical Committee TC95 Chair of the International Committee of Electromagnetic Safety. He's also participates with the Institute of Electrical and Electronics Engineers, IEEE. However, he is speaking as an individual, not for IEEE. As usual, we are required to record or state the following recording acknowledgement. This WebEx call is being recorded and may be posted on the Department of Energy's website or used internally. If you do not wish to have your voice recorded, please do not speak during the call or disconnect now. If you do not wish to have your image recorded, please turn off your camera or participate only by phone. If you speak during the call or use a video connection, you are presumed to consent to recording and the use of your voice and image. Please note that the question and answer session following this presentation will be included in this recording. So today's agenda, we'll discuss some logistics with the WebEx, some AU11 policy updates, further announcements, and then we'll have a short biography, and we'll turn the floor over to our speaker, Dr. C.K. Chow. So some logistics and audio considerations. We will be doing question and answer sessions at the end of the presentation. Please utilize the chat function for this effort. Only at the end of the presentation, we will allow for individuals to unmute themselves. You can try to utilize the unmuting function on WebEx, or it's easier if you can just hit *6 on your phone. But we do encourage utilize the chat function because we'll be monitoring that chat. If there are problems during the presentation, please again use the chat function. We do have staff that are monitoring that. It's really the best way to communicate with us. Our office, AU11, does not have control of your PC's functions for audio considerations. We do have a couple of recommendations for best audio experience. You definitely can utilize your PC's audio capabilities, whether it's internal or external speakers, maybe some headphones or headsets. They have different adjustments. You may want to use that. You can also manually call into the WebEx with this invitation. The number is with the meeting details. WebEx also has the function to call you directly. You can do that in the audio options within the WebEx. Right before when you log in, it has the option that you can press in a number. Unless you do it regularly, it will have your number regularly saved. If all else fails, you can request. Sorry about this. You can directly see. You can consult with your IT support for further assistance. Our worker safety and health staff. This is discussing our staff that utilizes or that participates in a lot of these WebExes, and this is our whole office. Our office is led by Mr. Jim Dillard. We'd also like to say, wish a warm welcome to our newer industrial hygienist, Mr. Michael Boley. Mr. Boley comes to us from, he previously had worked for the Coast Guard, and I believe he's also worked for different parts of the federal government. So, Mr. Michael, welcome. Also, we'd like to make a short announcement. We actually have had our AU10 director role filled within AU. Many of you may be familiar with him. His name is Mr. Kevin Dressman. Mr. Dressman comes to us from Enterprise Assessments for the enforcement branch of the Department of Energy. We're working with Mr. Dressman to speak at our next WebEx that should take place in November. So we'll have an opportunity to have him give some short remarks at that time. So welcome to both of those individuals. So some policy updates within the AU11 office. So technical standards, we'll start with those. The DOE Standard 1149 for the Safety and Health Program for DOE construction projects. Project justification statement memo is complete and the technical review process is underway. DOE Standard 1121-2008-001 for internal dosimetry for our radiation protection audience. The review process is currently underway, and that next update will happen possibly at the end of the month. DOE Standard 1239 about chemical safety management. The writing team for that excuse me, for that standard. We'll be addressing draft comments in their upcoming meeting. I believe that's also on September 30th. And then we'll be breaking into further writing groups to continue the progress. Different handbooks that are, sorry about that, folks. Different handbooks that we're also working on is DOE Handbook 1092 for the DOE Electrical Safety Program, currently under policy revision for the RevCom submission process. It is currently under a final technical review, and the plan for that is that it should be moving forward up the chain with an AU probably at the end of the month. So looking forward to that. Handbooks 1100 and 1101 are pending an AU1 approval for submission to RevCom. Next update should be later in October. Handbook 1130 for the radiological worker training program should be, it's currently the review process and revision is underway. Next update is at 9:30. And finally, DOE Handbook 1211 for activity level worker planning, control, and implementation is beginning a revision process and drafting the project justification statement. Next update should be in October. So a little bit about our past WebEx and some feedback. We really got some great feedback for the last WebEx that we had in July. The topic was engineered nanoparticles in construction, assessing exposure risk and controls and keeping workers informed. And also we had a second component to that WebEx that had our CARES program manager, Mr. Craig Schumann, speak about CARES program and mid-year update. Was very positive. We really appreciate the feedback. We will put the feedback survey that's actually on the slide, but we will also include that in the chat as the presentation goes along, so staff can have access to that as the presentation completes, and you can definitely go in there. The presentations typically are posted, the actual slide deck can be posted on the IHOS SIG website. That website is available there and will be posted with these slides. The actual video recordings typically take a little bit longer. That can take about a week or so, but we actually have those posted on energy.gov, and they're also through YouTube, so they are available for individuals to review these. As I mentioned, the feedback survey, we will include that link into the chat, and then we also will send an email following the presentation as well for those individuals. In addition to our survey, we also do offer certificates of continuing maintenance points, like if individuals have a certified industrial hygiene credential or a certified safety professional credential or other applicable credentials. We request that if you would like one of those, please sign up for that. It's in the feedback survey link. I believe it's the question at the bottom of the survey. So we appreciate your feedback, so we try to make an offer back. So thank you, folks, for those that participate, and encourage everybody to do that after the presentation. Again, feedback does remain anonymous. So some further announcements. So our WebEx series for 2021 is we have one more that's going to be in November. November 17th is going to be our last WebEx for 2021, the 2021 year. We're still working on a title for that. It's going to be radiation or rad topic focused. Definitely watch and email for that. It should be from 2 to 3 p.m. Eastern on November 17th. The schedule is posted on our energy.gov site, where we do post the videos as well. So it should be exciting. If you have suggestions, questions, or are interested in joining our mailing list, send me an email, please, and I can easily add your information to our mailing list. My email address is posted right there as well. Just a couple other announcements across the DOE enterprise. Previously, the DOE Beryllium Safety and Health Committee did have a fall symposium that was planned in late October. Unfortunately, we received some news that meeting actually has been canceled. So unfortunately, we just wanted to share that with the audience. However, the FCOG Worker Safety and Health Subgroup fall meeting is going to be virtual, and that meeting is still planned to occur through October 25th to the 28th of 2021. So some good information there. Further information, there's been definitely a lot of updates and a lot of information going around about COVID-19 and different operating statuses, et cetera. We have a lot of information that has been updated on the DOE's COVID-19 Hub website. We encourage staff to review that website if they have questions about that. Definitely the DOE safety plan for safer federal workforce is being posted and updated. More information is also available on the PowerPedia website, as well as the COVID-19 hotline. The phone number is right there. So all this information will be posted with the slide. Lastly, we get to our FIOSH monthly message for September. It actually talks about our more suggestions about working from home. So let me switch over to that video so everybody can see that. Just a moment, please.
The FIOSH team welcomes you to the Working from Home video series. While many of us enjoy the benefits of remote work, comfortable clothes, no commute, and frequent trips to your refrigerator or pantry, working from home can bring about some health concerns. So the health tip of the day is use the 20-20-20 rule. Set your alarm to take a 20-second break from looking at a screen every 20 minutes and focus on an object 20 feet away. It's not about being exact with the distance. Look out a window and find a tree or a lamppost across the street. Working in a small space, try going outdoors to rest your eyes. For more tips, visit the FIOSH information sheet.
Okay, we'd like to thank Carlos Kaufman and the FIOSH group for putting that information together. So thank you, Carlos. Also, there's a PDF document that we will include in the posting as well that has additional information regarding the 20-20-20 rules. So if members of the audience are interested, definitely read about that. So today's speaker, a little bit of a biography. His name is Dr. C.K. Chow. Received his PhD from the University of Washington from 1975. From 1977 to 2013, Dr. Chow worked for the University of Washington, City of Hope National Medical Center, and Motorola. He's currently retired and works as an independent consultant on EMF safety issues. Continues to serve as the chair of the TC95 committee for IEEE on electromagnetic safety. He's been responsible for exposure standards from 0 to 300 gigahertz from 2006 to the present. Currently, he's also on the advisory panel of non-ionizing radiation of the National Council of Radiation Protection and Measurements from 2016 to the present. Dr. Chow has also received the highest honor, the D. Arvidsson Medal for the Bioelectromagnetic Society in 2006, and received the IEEE Standard Association Lifetime Achievement Award in 2020. He's an IEEE Life Fellow and also a Fellow of the American Institute of Medical and Biological Engineers and the Electromagnetic Academy. So without further ado, Dr. Chow, we will turn the floor over to you, and you can begin your presentation.
Thank you very much, Joe. This is actually what happened starting from May the 4th this year. I gave a talk at IEEE, the Broadcasting Technology Society. They have a distinguished lecture on that day, and Joe attended that session, and he said, well, this is probably a suitable project topic for your DOE lecture series. I said, he asked me, see whether I will be able to talk about that topic for you guys. I'm really honored to come to here today to share my knowledge with the DOE staff all over the world. So the good morning, good afternoon, good evening all over, and thank you for spending your time to attend this webinar. And in the past, I have worked for 28 years in academic institutions and 15 years for industry. Well, I've never worked for government, but in my IEEE committee, we did have a lot of government staff from American government and from FCC, FDA, and NIOSH, OSHA, EPA, and DOD. And I didn't see anybody really from DOE, but today I'm so happy to share my knowledge with the DOE staff, and it's really my honor. So let me go through the slides. I have prepared 70 slides, so hopefully within the time frame we can go through this slide. But I don't expect you to read every word. I will not explain every word on the slide, and you have a copy of the slides afterwards. You can study the words afterwards. But in here, I have these materials I put on the slide for you. And today my outline will be a very brief history of what are the issues and what kind of controversies we're talking about, some key concepts. Then talk about these 5 subjects: research, publication, standard, regulation, risk communication. They all have some kind of controversies in there, so I have some conclusions, and I leave some time for the Q&A. So here is the a brief history of the issues. So after the World War II, and the first question came up was the big radar near the military installations, and what happened to the personnel, military personnel nearby the antenna? Are they going to be have any health effects from them? So the American government had a tri-service for military to study this extensively for 10 years. Came up some first exposure safety standard. And after that, in the 60s and 70s, the civilians also start worrying about the radio and TV broadcasting big antennas with megawatt power coming out from antenna. Are they affecting people? And so that was in the 70s, before the 70s. Then in the 70s, 80s, you have this radar range, the microwave oven, and we just call it microwave now, and just put into the kitchen, into every family, with the pregnant woman, the little kids looking into the window, see what's cooking in there, and are they safe for people? And in the 80s, we have police, male police, and when they were using the radar gun to track the traffic, and in between time they put the the gun between the legs, and some male police had a testicular cancer. Are they related to this RF exposures? And now in the 70s, and there's some papers come out about the high voltage power lines can cause a childhood leukemia, and are they really a health issue? And so they trigger some concerns. Of course, now we are talking about as a wireless communication from the mid 80s to 90s to now. Everybody, having cell phones in the pocket, and you see the antennas on the roof and on the towers and on the posts and everywhere. You didn't see that before, but now they are all over the place. Are they safe? We have mobile phones from first generation all the way to 5G, and pretty soon, a few more years, the 6G will be coming out. So with all this all around, also we have Wi-Fi just about every home. You have the Wi-Fi router, you can get on the internet, and also you have a smart meters for the utility company to monitor your electricity use, and RFIDs used in many places, the stores and all that. The last one is actually the most severe one. It's the wireless power transmission, but not too many people worry about it yet. It's such was for the electricity, for the electrical car, for wireless charging, and that's talking about kilowatts power. And are they really safe for people? So this is the brief, quick summary of what's happening. And so in terms of common understanding of this
Dr.
subject,
Chow,
yes.
I apologize to interrupt you. Is there a possibility you could possibly move the volume up? And some staff are having some challenges hearing you on your microphone. Is there a possibility you could go maybe audio and see if you could try to raise your microphone volume?
Let me try, see what happened.
Sure. Thank you.
Okay, because I thought I'm using the mic, the earphone. I thought it should be pretty clear. Let me go back, see what to do.
Sure. Maybe on your computer it might be.
Yeah, I have to. Oh, can you hear me?
Yeah, that sounds a little better. Please continue, Dr. Chow. I think it's a little better. Thanks.
Can you hear me?
Oh, yes, that's even better. Yes.
Even better?
Continue.
Okay.
Thank you, Dr. Chow.
All right. Okay. Well, that's the most important. If you don't hear me, that's not good.
No problem.
Okay.
Thank you.
Now, let's see. Can you see the screen yet? No?
Not yet.
Okay, let me, okay, say share.
Perfect. We got it back up. Thanks, Dr. Chow.
Okay. So this one, this slide to show the general and the common understandings of the subject. The microwave or radio frequency is dangerous, and we don't know enough about its effects. And there are many reports showing they are so-called non-thermal effects, and radiation can cause cancer and many other diseases. The standards are not protective, and so we need a precautionary measure to be safe than sorry. Okay, is that pretty much you guys' understanding on the subject? And I'm giving you a summary, just the contrary to what had happened. It's in green color. Yeah, they are dangerous, only in very high intensity. Yeah, they can kill people. And we have about 70 years of research on this subject. And this non-thermal effect, either not repeatable or no proven health effects, and can cause cancer or other diseases, but really no proof and no mechanism other than heating and the electrostimulation that we'll explain more later. And the world, if not a protective, but the worldwide expert groups and health authorities agree they are. And safety standards already have a large built-in safety margins, so we don't need to be more precautionary. So you can see the two different opinions between the black ink and the green ink. So this is a huge controversy here. Which one is correct? Which one should I believe? So I borrowed this slide from the WHO and from 2020 or 2010, 11 years ago. You see here, when we talk about radiation, and on the left side is the public health real effects. And this is in terms of severity, and the lowest there should be EMF, electromagnetic field, and X-ray, the radon, then ultraviolet. But in the public concerns, they are just opposite from each other. So what can be the problem? So what are the causes of the controversies? So here I have studies for almost 50 years on this subject. I understand it's trouble of the whole concern. The root of the concerns is the term radiation. When you talk about radiation, you immediately think about the atomic bomb exploded in Japan twice. And another 3 nuclear accidents. The latest one was 2011 in Fukushima in Japan. And of course, every year we go to a dental office, get an X-ray. When we get an X-ray, we have this heavy apron put on our chest and then cover our chest and our neck area. And you have go to the radiation department, and they have all these radiations, warnings all over the place. So that's called nuclear radiation. Unfortunately, this triangular yellow sign is very similar to what we have used for the radio frequency. Even the middle is an antenna with waves going out, but they are basically very similar. So a lot of people even use the cell phones. They say, okay, here's radiation from cell phone, and use the same symbol as this nuclear radiation. So here you see, I have used the term here. Instead of call it the radio frequency radiation, here the term is RF exposure. This is what we have used in IEEE, FCC, and WHO. We try to avoid the term radiation to confuse the general public, so they will equate the two as all radiations and cause unnecessary fear or worry about this particular radiation. So I think many of you are familiar with this, but just for others who are not in this field, I just showed you a simple diagram and from it's called electromagnetic spectrum from DC, Earth's magnetic DC static field, all the way to 10 to the 13th to the X-ray and gamma ray. This is all in the frequency going up and the wavelengths going higher over this side. And there's one energy called photon energy. It's depending on the frequency. When the photon energy is more than 10 electron volt, above the visible light and above the ultraviolet C band, they become ionizing radiation. And below that is called non-ionizing radiation. And here today, we are talking about the radio frequencies and all that. It's well below the photon energy of 10 electron volt within the non-ionizing radiation. So in terms of words, and here's the difference between the two. The ionizing radiation, the photon energy has sufficient energy to change the chemical bonds and the atomic structures, and such as like DNA or the electrons, they can knock the electrons out and cause the DNA damage. And this they can have confirmed health effects, including the genetic damage. So that can cause cancer or things like that. And also this effect is cumulative. So they can wear the badge to see how much exposure you had during the year and all that. So this has been known since the radiation started in 1990. Before that time, like Madame Curie, she didn't know. So she died of all the cancers because she was handling this ionizing radiation material without any precaution. So, but now we have more than hundreds of years of research on ionizing radiation. We know much, much more about the ionization effects. And now here we are in this non-ionizing radiation, including the radio frequency, and has a low photon energy, like millions of times below the 10 eV. So you have insufficient energy will not cause effects like this ionizing radiation. So far, the only confirmed RF research health effects are related to the tissue heating. They are the levels of well below the much higher than the wireless communication. They can cause tissue heating because it's a very high intensity. And also there's no known chronic or cumulative effect different from the one above. And this research has been since after the World War II. It's about 70 years. But I want to mention to this here on the left, the picture here, this is a diathermy used in rehabilitation medicine in physical therapy for treating muscle pain or joint pain and all that. Even like this, they are very high power, and they have been using this since 1946. And like millions of people have been benefit from using this technology for medical application. So when we have concerns, what we do? That's what the scientists is their job. The researchers, professors, the university students, graduate students, they go into the lab, start doing the scientific research, and when they have results, they go to the peer review publication. So either put into a library or into the clouds today. Now, after you have all these publications, committees like us, IEEE, then we'll sit down and collect all this information, relevant information, and discuss that and come up a consensus standards. And we published like this year in 2019, C95.1 standard. And government regulators such as FCC, they will take a look at the existing standards and adopt into regulation and make into a law for people to follow. So this is a chain of reactions. It continue to evolve to improve the exposure, the database, and also improve the standard, improve the regulation. And in the meantime, they have a communication between the researchers or government agencies to the general public, to the media. So these are 5 bubbles, what we are talking about, and we want to analyze individually what can be the controversies from these 5 areas. And first, let's talk about research. How do you do research? And this is 4 studies according to the WHO or IARC, the International Agency for Research on Cancer. And they said the most important studies are epidemiology studies because they involve large population, all kinds of diseases. And so that's the most important, directly related to human health. But the trouble is, in this type of study, they can have all kinds of recall bias, selection bias, so-called confounding factors. And so there are other studies like putting people in the human in the lab to do controlled experiment, all that. But this one also has its shortcomings and advantages. And the mostly used are the animal study. You can do whatever to animals following the regulation, and they have a shorter generation time, and you can get the results faster. But they have a different metabolism, physiology, the lifespan. So how do you extrapolate to humans is also another problem. The least weight study are the in vitro studies. They are good in terms of very fast and they're very cheap to accomplish something, get the students graduate very quickly, but they don't really, they are very low level in vitro. And how do you extrapolate to humans is a big question. So in terms of all this, the database, the thousands of papers in IEEE database, we have more than 8,000 peer-reviewed papers in there. What the data, WHO said about this current knowledge on this field, in terms of biological effects or health effects from the EMF. And here's this two sentence. Scientific knowledge in this area is now more extensive than most chemicals, and current evidence does not confirm the existence of any health consequence from exposure to low-level electromagnetic field. What do you mean by low level? Low level means below the current international exposure guidelines. So you can find the code from this link. So we come to this center of this dispute or the controversy is this slide right here. So it's like in the quality of science. It's like in a university or any school among a population, a class of students. At the end of the quarter or a semester, some students will get A, some will have B or C, or some even get flunked out. Yeah, same as in science. So whereas you have a top, the A group they are the confirmed and established science. And what are they? They are facts. And this fact is like the bottom says, it can be proven and must be always true. No matter what you do, it's always like this. So it's a fact. And the other B, C, D, E, and F, they're starting at question marks. They are not really proven. They're even contradictory. And some clearly there are some flaws or artifacts in the study. And they are purely junks, and they're not even just peer reviewed, just the newspaper report or just the rumors. And all these things are formed so-called opinions. And here you float all the way to the A to be confirmed, you are just opinions. So here's a conflict between facts and opinions, and that means there's a established fact and the versus possible. So if you are talking about this group of literature, definitely you have a very different opinion from the people talking about the top A category scientists. So that's why we have a continued controversy, debate in this field, depending on what you're talking about. And let me give you some, a story about myself. How do I get into this about almost 50 years ago? 1971, after I graduated from Washington University in St. Louis, I moved to Seattle and to study under Professor Bill Guy in 1971. At that time, actually, the gentleman on the left here, Jack Anderson, he was the reporter for the Washington Post. In 1970s, he reported that the U.S. Embassy in Moscow, the staff were exposed by the Soviet Union with some kind of a microwave, and that's called the microwave Moscow syndrome, and similar to what we are hearing nowadays, the Havana syndromes. So he was saying, what's happening over there? And in the meantime, the safety standards between the Soviet Union and Americans, they are 1,000 times difference. The Soviets are very stringent. They say very, very dangerous. And Americans say, no, we don't see that dangerous. So they are 1,000 times difference. So that time the FDA came up some research fund, and Dr. Guy got some funding. So he asked me, he said, was this a new graduate student arrived? He said, would you like to work on this microwave effects on the nervous system? I also said, oh, okay. I didn't know anything about it at the time. And why on the nervous system? Because humans have a brain with billions of cells in there. So all this electricity all conducted by electrical signals. So the microwave, whatever, must be affecting the brain the most. So that's what the Soviet scientists believe. That's the most sensitive tissue. That's why I was assigned to work on that. So I spent the initial time to do the literature survey. A lot of government summarized the reports, and many of the abstracts and the very short papers from the Soviet Union. And there are hundreds of papers on that. And that was interesting. Even that time in the 70s, I started to see, wow, how come these papers come out from the medical schools? They're all showing these RF microwaves are good for you. They all treat all kinds of diseases and make things better and make you improve the health. And if you look at the papers from the hygiene department or the environmental health department, they always say everything's bad. They can harm you, can kill you, can do all kinds of effects on the body. So it's very controversial. So that's why I was put on to study this. The first one I studied by a professor, they exposed isolated nerves in the waveguides. He found a huge effects from very low power, don't even see any temperature rise, but huge effects on the action potentials. So I spent some time to design a temperature controlled waveguide, and I said totally dispute the Soviet study. If you can control the temperature of the nerve or the muscle, nothing happened. Even up to kilowatts, the peak power from the radar and all that, nothing happened to them. No effect on these tissues if you can keep the temperature very constant. So after that, the short study, and we get a second grant from the National Science Foundation to study the so-called microwave hearing effects and why people can hear microwaves. That was reported by American scientists and Alan Fry. And he said that he did some animal studies on rats. He said he had evidence to support the Soviet scientists. Yes, microwave pulses, radar pulses can trigger the nerves and cause a hearing effect in the rats and also presumably in the humans. So we spent some time on this study to show, no, that's not the case. And this is I don't have time to explain all that to you in such a short time, but that was not true. So you see, in my thesis, in the 4-year study, I graduated in 1975, and I found there's huge discrepancies, in the history. Even the time I was studying, and to show, no, that's not true if you do it correctly. So here I have two slides to summarize the complexities of this biologically. This is all the animals I've used from frog legs, using the isolated sciatic nerves, and all the way to humans. They have a different species, strength, sex, age, and all that. And in vivo study, and in vitro studies, they use a different flask or culture dish or tube, test tubes, and you have a monolayer cells, cell suspension, isolated tissues. They all have different effect depending on how you do it. And then you go to engineering complexities. I learned from University of Washington and also Motorola, and a different exposure system to expose cells in there. And this is the circular wave, the waveguide I use for studying the hearing effect in guinea pigs. And here's the control temperature control waveguide I used to study the nerve muscle effect using the temperature control, and also the others I will show you some later on the chronic exposure animals. The one down below you see, for the same human figuring and exposed to E field and magnetic field, they have a totally different absorption pattern inside the humans. So you see, this is a different exposure system, different far field, near field, dosimetry depending on frequency, orientation, tissue property, and all that. And also different resonance frequency and different modulations. Also experimental artifacts. How do you control the temperature in the cell culture or in the animals? It's a huge engineering complexity. So there was a need of this. So I wrote a review tutorial article in 1996 in the bioelectromagnetics. If you have interest, you can take a look at that. So here I use the cartoon from Gary Larson from Seattle. And say, here you have a boat and going in circles. You say, what? Well, how come we are going in circles? You can see, because there are two different crews that have a different ability to row the boats. And this is exactly what happened in this field. We have 70 years research. We are still circling around in the ocean because there are some groups have very good biologists, but very little engineering, and also vice versa. So I will have one example to show you later. So here is the example of the chronic study. And this is a result of the USSR, the Soviet Union exchange program between the two countries. You find out why we are so different in exposure limits. And this is the very first study we agreed to conduct in each individual countries. And this is the first one I did with the rabbit exposed for 3 months, and see what the animals, the exposure happened to the animal. We measure all kinds of parameters. We did not see any effect at 0.5 milliwatt per square centimeter, which is 2450 megahertz, a continuous wave. But at 5 milliwatt, we only saw one effect. That's this one showing on the right side, is the food consumption. During the microwave exposure, they eat less. They eat less because now our hypothesis, because they use the energy from the microwave, they don't feel as need to eat that much to keep the their body heat up, and also for the whatever metabolism, so they don't eat as much. Other than that, we didn't find anything, including cataract and blood parameter, chemistry, all that. Nothing happened. But if you look at the Soviet study, they exposed only to 10 microwatt. It's much lower power. They found all kinds of chemical and the immunological function changes in rats. So this is this kind of a controversy continues even depending on where you do it. And this is another American study from Dr. Susan Coble in 1965 from University of Arkansas. She exposed rats in this resonant cavity, and she found that there are behavior effects from a 1 milliwatt measured by a probe here to measure say only 1 milliwatt per square centimeter, very low power, and then she found a behavior effect. So Professor Bill Guy visited the university and measured the cavity and tried to replicate the same study with simulated rats. Here the pink simulated rat and drinking the water bottles like they did in the Arkansas, and with a stainless water tube. And here is showing the half the rat with touching the tongue touching the stainless tube, and with the legs and the tail touching the ground mesh ground plane. And they then did the thermography viewing of what happened in this rat during the exposure. And we have found out and this 1 milliwatt per square centimeter can induce behavior effects and actually cause up to 185 watts per kilogram. This is very high exposure intensity, can cause intensive heating in the tongue, in the legs, and the tail. Of course, they can cause behavior change. But for biologists, they didn't know. They have no way to know this detailed dosimetry inside the animal. This is an example from UK. And my friend John Tattersall, he reported in 2001 showing low level can cause behavior, some electrical activity in rat hippocampal slices. And actually, he reported this in 1999 in Long Beach, the Bioelectromagnetic Society. I did tell him, hey, John, I think you get an artifact in your study. And he was not sure about that. So this paper was published in 2001, and still there. Many people still quoting this study showing their low intensity can cause effects on the rat brain. And in 2007, we had a meeting, IEEE meeting in London. And John, I invite, he came over to our meeting and presented this data to us. And in this one on the left, this was an old study he had before showing this at 700 megahertz, and had a 4.1 milliwatt per kilogram, and can cause a change in the electrical activity in the hippocampus slices, and showing that's what he reported in the paper. And so after he did something to the orientation of the electrode, make it perpendicular to the E field, and he used it on the right side, used a new system, and the same frequency, but 6 times more power, 29 milliwatt per kilogram. And here you see during the exposure, there was nothing, no effect at all. So this is a example of say how you do it, make you have a different results depending on your metallic electrode orientation, because this can cause induce the heating in the tissue. Here is the Australian study. And first author was Ripiccioli, Michael Ripiccioli, before he joined the WHO, become the chairman of the EMF project. They exposed the mice, transgenic mice, and in this exposure system, similar to from University of Utah. And inside an anechoic chamber, in the middle, it has an antenna. Around that's 10 cages. In every cage, with 10 mice inside, expose them for a long time. And they found out that after exposure, there are more cancer in the exposed group. And that really shocked the world about this study. But the weakness of this study is that because animals can touch each other with 10 animals moving around, they don't really know how much animals getting what. And also they can have this hot spot, like I showed you earlier. They can touch animal each other. They can cause the induce RF current issues. So Motorola at that time designed a better system. We call it Ferris wheel. We can simultaneously expose 40 mice with air conditioning and with fixed orientation in there, and expose. We made 15 of these wheels sent to Australia. They did a study, exposed the 1,600 mice, and with the 4 different levels, 0.25 all the way to 4 watts per kilogram. and this is the basis of the IEEE and ICNIRP limits, and they found no significant effects. So you see this, whatever they reported before in Australia, and then using a better control system, they don't, even with a very high power, they don't see any significant effect. So you have to see what is the problem. And this is my own study at the University of Washington, and sponsored by the Air to simulate a radar from pulse defense radar effect, possibly on humans. So we use this system to expose on 200 rats, 100 exposed, 100 control on a pulse field for a lifetime, 25 months. And they use the circular waveguide, and this is a specially designed water bottle. So when an animal drinks the water, will not get a shock. And also any feces or the urine will come out to the outside of the waveguide, will not interfere with the absorption inside here. Also, with the circular polarization, the rats, no matter how the rats move it, inside the cage will not have too much change in the energy absorption. So we expose them in there for 25 months. And within the 155 parameters we measured, and all the health parameters we try to measure, and only one parameter, is the cancer, of the metastasized cancer. There are 18 animals in the exposed group has metastasized cancer. In the sham animal, only has 5. And in terms of benign tumors, non-malignant tumors, they are not much difference. Actually, the 62 to 53 out of 100, statistically no difference. But so only this one statistically showing is significant. However, exposed animal at the end of the study, 25 months, there were 12 animals exposed, and the 11 animals in the sham. So there's one animal more in the exposed group. So in terms of longevity, there are not much difference. So why the metastasized is more? We don't really understand it. So anyway, so this study was published in 1992 in the Bioelectromagnetics. The Air Force to continue to fund 2 additional universities, one from Georgia Tech and one to Trinity University in San Antonio, using mice for 2 different frequencies, 435 megahertz and 2450 megahertz, and both studies show negative. There were no effects, no cancer induction in the mice for 2 different frequencies.
Dr. Chow, did we lose you? Sorry, folks. Just bear with us just for a minute. I think we're having some audio issues. Just a minute, please. Actually, I think I stand corrected. I apologize. I think we may have lost our speaker temporarily. Let me see if we can get back in touch with them. I'm sorry. Please bear with us.
Okay. So this we stop at this number 30 slide. This is the sponsored by the Air Force to continue to see whether we can repeat the study what we had in the first study at the University of Washington. And these 2 studies found no effects from the this one. Okay. Okay, are you showing this from your place, Joe?
Yes, yes, I have it up on my screen. No, nope, you just need to speak, sir.
Oh, okay, all right. So I'll let you do it then. Okay, go to okay, now NTP study. This is the most important one. The whole world has been seeing this study. And this study was spent $27 million. It's from the government lab at NTP. The thing is, this original pathologist from NTP program and had a conclusion says there are some significant difference. They are equivocal evidence showing they are different. But this results, they were changed in the open meeting to open to the other outside, the participants, and the results got changed to clear evidence to some of the numbers. So that was the one causing a lot of concerns, and there are clear evidence from this government report. So let's look at some of the main slides on this first one on the brain. And you see here on the previous, here you see the control column has 0 animals, and historically should be 2% animals. 90 animals in each group should be at least 1 animal, whatever has a cancer. But no, this is 0 for control. And you see in the GSM modulation, there are 3, 3, and 2. Well, yeah, seems to be some numbers, but how come at 6 watts, the highest power is lower? So that was not really significant. Okay, but look at the CDMA from 0, 0, jump to 3. Whoa, this is the higher the power you have the effect. So this is the one statistically show a significant difference for the CDMA. So that's for the brain. The next one on the heart. The heart, next slide on heart. The heart, okay, also shows 0 for the heart schwannoma cells in control. And for the GSM, it's 2, 1, 5, and the other one is 3, 2, 3, 6. So it seems to be, the higher the higher the number. So you see that both of them are having significant effects. And this is what the most important study out of this, all the animals from mice, from rats, both male and female. There are 4 groups. And this is the only group showing in the male rats have this effect on the brain and the schwannoma. And that caused a lot of attention, a lot of concern in the world. Okay, let's look at the next one. It's a very clear one. You don't even need a statistic to see there's a big difference. The black dots are the 28%. They are the control animals at the end of the 205 weeks, and only 28% left in the non-exposed group. And then the 50, 55, and 68% are the higher the exposure, the longer the animals, more animals lived at the end of the study. And also you have to know the difference. And this is a whole body exposure. So in the standard FCC and IEEE standard, what is the public exposure limit for whole body? Is 0.08 watts per kilogram. So that is 75 times higher. The 6 watts is 75 times higher than the general public exposure. We know it can cause heating effects in animals. And why the animals live longer, I think depending on what we had a study in on rabbits, the more you expose them, they don't eat as much. And unfortunately, in this study, they did not measure the food consumption in animals. So when animals eat less, they have can have a longer life. That's a hypothesis, but we don't have the data for food consumption in this study to validate that. So this is a controversial thing in the world, and that's why next slide. And the Japanese and Koreans, they are conducting a validation study and using the same whole body average, but they only use the 4 watts per kilogram. But because that's the current basis for the safety standard, using the CDMA, use the 70 animals, male rats for each country. So total of 140 rats in both countries. And the study is going on. Maybe next year, and they will finish the study, get the report done. Hopefully 2022 or 2023 for sure, the results will be out. And in the lower corner here, this is a study written by Joe Elder and talking about the survival and cancer in lab animals. And that time he had 18 studies to show that long-term low-level exposure does not have any adverse effects on survival and cancer in lab animals. And here is this one is pretty high level though, 4 watts per kilogram. But I think after this study is done, we need to update on this particular long-term animal studies and see what the weight of evidence saying in this field. Okay, next is on the real data from humans. And this is NCI data on brain cancer because we always hold our cell phone next to the brain. So there's a concern whether it can increase brain cancer. So this is NCI from 1992 to 2018. The green dots are the new cases. The black triangles are the death rate. So you see over the time, there's a slight decrease in terms of the survival or the new cases. In terms of on the right side, you see a curve going way up. That's the mobile phone use rate. So you see a big increase on mobile phone, but in terms of brain cancer, it's a pretty flat. Actually, it's a slightly going from 7.05 to 6.33 over the years. So you see this is real human data to show the trend. Okay, the next slide, from different country, from Sweden. And there's two curves. One is for the older people, one is for the younger people. And they'd have a longer time, even from 1970s to 2018. So before the cell phone started in 1986, before and after, you don't see too much changes in the two different age group in Sweden. Okay, next. So the International Agency on Research on Cancer, their job is to analyze anything in world, and so far they have done 1,029 agents, whatever exposures, and they put into whatever they study into 4 different categories. And one is definitely can cause cancer. There are 121 of them, including smoking or too much sunbathing, or even eat the hot dogs or the air pollution. They are known carcinogens. And the 2A is probable carcinogen. There are 89 of them. And 2B, that's the lowest one of the category, is called possible carcinogen, including the Koreans love that, the kimchi, and the car exhaust, and the DDT, or even baby powder, the Johnson & Johnson's baby powder, and they have a so-called possible carcinogen. There are 319 in there. And the other group is, they don't know. It's about half of the 500 of them, not classified. We don't know what they are. And in terms of the EMF, in 2001, the power line magnetic fields was put into this 2B possible. And in 2011, the RF fields like mobile phone or base station, they put into 2B possible carcinogen. But this also caused a lot of concern around the world. See, even WHO says a mobile phone can cause cancer. But here you have to see this is the lowest one of the 3 categories of the 2Bs. All right, next. So after the 3 weeks after the IRAC announced that the possible 2B of the RF field, and the WHO EMF project issued this fact sheet on the mobile phone safety. And in there, there's a question: are there any health effects? And the answers in there is one sentence here, 2 sentences. A large number of studies have been performed over the last 2 decades, and to access whether mobile phones pose a potential health risk. And to date, no adverse health effects have been established as being caused by the mobile phone use. Okay, so you can find that on the web. Yeah. Next. So in terms of this expert reviews and IEEE website, we have this link here. You can go there to see from 2010 to now, there are 88 expert group panels or government health agencies put their information there. In general, this in the red sentence here, no adverse health effects have been confirmed below the current international RF safety guidelines or exposure standard. That means the ICNRP. I'll show you that later in the IEEE. Okay. Next. So in terms of research here, and it is a problem, the controversy, because the ionizing radiation has been much earlier. So many of the people doing the ionizing radiation come to the non-ionizing radiation to do the research, but without any knowledge about the complicated engineering of the symmetry. So that's a lot of wrong approaches of making the studies and cause some problems. And many of the scientific studies, it's not repeatable and they're not consistent. That's the problem. And it's a scientific study, you must be repeatable. Any unique findings, well, the only you can find it doesn't mean you are the best. It's really unlike in the art. So any observed effects, we must know why it's causing it. But many of the effects cannot be even repeated. You cannot even study why it's causing an effect because it cannot even repeat it. So that's what this example. It's an old saying. Very easy to drop a big rock in there, but it takes a long time, big effort to get the rock out. That's what exactly happened in this field. You publish something in the journal, and people have a hard time repeating it or resolve the problem. Okay, next. Okay, then problems in the when after you do the research, you go into the publication. And over the many years, I've been editing many the papers or associated for the bioelectromagnetics, and then we found out there are some cultures they don't allow to publish negative effects. If you don't have no effect, they don't let you publish. They only publish positive effects, and some journals are doing that too. Yeah, it's you have nothing to report. Why do you publish it? They reject it. So also actually some even very good journals, they may have very good reviewers in biology, biochemistry, whatever, but they don't have expertise in dosimetry or engineering or exposure systems. So let some papers get published, and even in very good journals. So many published papers don't have enough details how for you people to evaluate or for replication. So this kind of papers, even they are peer reviewed, they are not necessarily good. So they are not useful for a standard setting, not even good for doing a review. So this is a big problem because they don't have enough attention to what engineering and biological details. Yeah. Okay, next. So I give you an example of this published study. And in 2003, we made a trip to Tel Aviv University. We heard they are coming out with a study showing they have found a non-thermal effect in cell cultures. So I took a temperature probes, a non-perturbing temperature probes. They did not have it in their lab, but I had one. I brought it in there to put in the culture media. I discovered there were 4 degrees temperature rise in the 75 ml culture flask. And I said, no, this is not non-thermal effect. This is some thermal gradients of 4 degrees thermal gradient in here. And the engineers say, yeah, we probably should redo it. The biologists didn't say anything. I think that the reason is because they already submitted. And the end of the year, the paper was published in the Bioelectromagnetics Journal. It's a very good journal. It was published. And within 5 years, they received a second place award from the Society for the most influential journal paper for that year. So you see, even a pretty poor paper, because it's claimed a non-thermal effect, it's get a lot of citations, and they get attention, they get an award because a number of citations. So this is, can be difficult to say which is really influential, but it happened. Okay, next. So we go to the in terms of standards, and to me, standards should be based on science. And of course, standards should be protective. Otherwise, what do you call safety standards? And also must be practical to implement. You cannot implement something you cannot cannot use it. For example, you cannot, because the cars can hit people, can kill people, you cannot limit the speed limit to 5 miles an hour, or you cannot use that. All right. So let's go to talk more about standard. Next. So what are the standards we are talking about? In terms of safety, there are 3 different categories. One is exposure standards in terms of human safety. And currently the standards usually are 2 tiers, one for the general public, the other one for the occupational group. And the other is the assessment standards for the emission from the devices. And the third one is on the EMI interference on the medical devices. So today we only talk about the first group. Okay, keep going. So here, who can set the safety standards? Currently, there are two groups. One is the International Commission on Non-Ionizing Radiation Protection. They have only 14 experts from universities and the governments, but no industry representative. But they are endorsed by the WHO. The other group is IEEE. We have a larger group, and it's open consensus. Anyone can participate. Okay, next. And currently, ICNIRP has two guidelines, one for the low frequency, one for the high frequency. Next. And this is the IEEE has a long history from 1960s. We came up with a first standard in 1966, only 2 pages. And the latest one we have is in 2019 October, and that one already up to 310 pages with 1,550 references. Okay, next. So this is the cover our safety standards. Next. So here we have, when we derive our standard, we have listed the effects from the most severe to the least severe of 1 to 6, and we draw a the red line at under number 4, and below that micro hearing effect. You can hear it like I studied before. That's only what you can hear. What's wrong with it? So then we don't consider that's an adverse health effect. So we just say, okay, above the number 4. The red line 1, 2, 3, 4. We will try to prevent that from happening. And how about the number 6? You see the next slide. And because the 70 years research, there are all kinds of low-level effects reported and all that, but there's no theoretical mechanism for that. And also, they are not very difficult to repeat, and also really no health effect. So we consider this so-called reported effect remains still speculative. It's difficult to be used for the standard setting. We only try to prevent adverse health effects. They are proven. So that's the difference. Okay, next. These are the standards you can get all for free. You can go to this website, and if you're not IEEE member, you just sign up an account, and you can download this all for free. Okay, next. Okay. But what I have been talking about are the international ICNRP and IEEE. These are the other so-called activist group. And the first one have a very similar name as IEEE, but their main point is on the precautionary principle. The other group is from the United States. The first one is from Italy. The second one is from the United States. And it's called Bioinitiative Group. They come out with a report in 2012, and they have accumulated a lot of positive effects papers, and they say they are even not proven, but they are possible. So we should be precautionary and set a limit like 0.3 nanowatt per square centimeter is a precautionary limit. And well, this level is pretty low. Yeah, it can be safe, but I'm sorry, if you have to apply that level, nothing can be used, and we have to shut down all the modern technology. Okay, next. So there are the controversy in terms of standards. The IEEE and ICNIRP guidelines, there are some differences in there, but mostly they are harmonized. We continue to try to harmonize. But however, the activist group, they say, oh, you guys, IEEE and ICNIRP, they are not conservative enough. We want to be more precautionary. They want to continue to demand lower exposure levels and to avoid any possible biological effect. So that's caused a whole bunch of controversy on standards. The next. So in terms of protection, for the government to protect their people, the citizens, and there are two different approaches to do that. One is like we, as IEEE ICNIRP said, we protect against established adverse health effect. The activists, they want to protect any possible biological effect. So this is a very different approach on that. So we see the next one, the real example from Russia. Okay, this is from Ripacholi in 1983. He said if you axis on the top, these are the health hazards, adverse health effect. If you know, put a threshold there and put a safety factor, and you can see the dash line, the upper dash line there. And the other activist groups say, no, there are some circles, biological effect. We should below that. So the difference between the two dash lines is very big. Okay, next. So we show you a real example from Russia. This is exactly currently what they are doing. So Rebacholi worked with this Yuri Grigoriev, the paper published in 2012 in Bioelectromagnetics to study the scientific basis for the Soviet Union and the Russian RF safety standard for the general public. And let's see what they say here. The top line says the people should not have to compensate for any effects produced by RF exposure, even though they are not proven to be adverse health effects, and they do not cause any possible biological consequence among the populations. This kind of approach definitely have very different limits from the IEEE and ICNIR. So this is another big difference. All right, next. So in terms of, I have two maps here to show here. This one for the portable devices like cell phone or two-way radios, and we have the one in yellow color is pretty much following FCC. FCC in 1997 adopted 1991 IEEE standard of a 1 limit, and the others, the green color, follow the ICNIR, the guideline 1998. So you see, dominantly are the green color, but they are the latest one is from India. The yellow color in 2012, they decided to follow FCC. So that's the conflict between the two colors in the world on the portable devices. The next one is about the base station. Base station GSMA. Their website has you click on any country there, you can see their what's their exposure levels for the base stations antennas. Okay, go to the next slide. I have put into 3 different categories. The people following ICNIRP guideline, they are majority because they are promoted by WHO, and the other 12 follow FCC. They use the old 1991 and the 1986 NCRP standard, and so some people follow FCC. And the third group is their limits are below both IEEE and IEEE, ICNIRP. And there are also 2 groups. The first group are the communist or the Soviet group influence, like China and Poland, Russia, and Bulgaria. And their limits only apply to the general public. They do not apply to military at all. Otherwise, their military have to shut down. Okay, the second group is all the countries in the world, including Chile, Greece, India, Italy, Liechtenstein, Switzerland, and they use the precautionary principle. They make it even lower than the ICNIRP. And so that's I can see the changes around the world. Okay, next.
Hey, Doc, we're going to give you about a 10-minute warning, so if you could try to wrap up the next 10 minutes, that'd be great.
All right. So in terms of the regulations, you see if they have other agendas to consider, not science, they can have a very different regulations limit. So if the non-scientifically based factors should not be included in the setting the limit, otherwise it can be very arbitrary. Next. So now it's communication. Communication is very complicated. The wireless, the technology is very complicated. What do you mean 2G, 3G, 5G? CDMA, GSM. People don't understand that. They just want to be safe. Okay, but the trouble is science cannot prove safe. Now, it can prove it's dangerous, but you cannot prove safety. That's a problem for science. And the precautionary usually can increase the concern. I'll show you an example. So the WHO is really against any arbitrary precautionary levels. Next. So now in terms of communication, usually by media, that's what the general public use. And they are very different from science. There you can see on the list here, one from the consensus truth, the other one always looking for news, conflicts, and they continue have reporting on the media in the media. Next. And the media has a lot of trouble because usually the experts, they come out to say something. Are they really experts? Or if anything come out on the news may not be verified. And they also, the media usually spotlight reporting, not the weight of evidence looking at everything. So they want to attract the audience. If you have nothing to report, nobody is interested in it. So all this misinformation can propagate very fast and continuously. The correction is usually very difficult to do. It can be in the newspaper, page 35 in the corner, very small little one. Everybody will miss it. So unfortunately, the general public, they acquire the knowledge from the newspaper or watching TV. They are not looking at IEEE transactions, microwave journal, the technology and all that. So therefore, I have a request from the media reporters. Say, hey, you scientists, please give me the reliable information. Don't misguide us. We don't know nothing. We just report whatever you gave me. So that's what the responsibility should fall back to the scientists. Okay, next. So I'll give you one example. This is from University of Utah, showing this adult 10-year-old, and to the right is for a 5-year-old child. You see a huge difference in terms of cell phone energy propagation in the brain. Published in 1996 IEEE journal. So I talked to Dr. Om Gandhi in 1999. He said, well, I think I need more research. So you see that, okay, this picture has been used by the activists. It's just about any activist group or website to say this is children should not use a cell phone because of this picture. Okay, you see the next one. In 2002, Dr. Gandhi, next slide, I show this slide here. Now it's a properly scaled adult, 10-year-old, 5-year-old. And you see relatively, they are more closer to the center in the smaller brain. But from the ear to the inside to the purple color, they are identical because this is supposed to be physics. For near field couple, the energy coupling should be about the same. So it cannot be like the previous picture. However, this correction, no activist will use this picture and put it in their website. Okay, next. So I said earlier, precautionary can cause more concern. This is 2010. And in Europe, they have a Eurobarometer survey. And the question is about how concerned are you on these possible potential health effects from electromagnetic fields? And they have a different reactions from different countries. In Europe, 46% is the average in the middle. Then the above that, the highest ones, Greece and Italy. And 81% people are so afraid. And the lowest is Denmark and Sweden. They don't really concern. So what's the difference between the two? The top group, because they have stricter legal safety limits from the government. They are continuing to have strong precautionary advice by the government to their citizens. And the bottom countries they are following the ICNIRP. They have compliance program. They communicate better with their citizens. That's the difference. Okay, next. Okay, the conclusion of this controversy. The bioeffects research is very difficult. Require both biological and engineering expertise. And the publication quality varies. And very few really confirmed health effects. Research results are to be used for the exposure limit, depending on whether you're talking about established health effects or possible biological effects. They can be very different. If a government regulation include the political consideration, make the regulation so controversial. Risk communication by media, also on spotlight of unusual reports, they also cause a lot of confusion, a lot of concern. So the general public are really confused by these conflicting scientific reports and harmonized standards and regulation. Okay, next. So over my 50 years research in this field from 1971 to now on the standards and research, this is my conclusion of this. This is my view, personal view, and hopefully it's more based on facts. Radio frequency exposure is very different from nuclear radiation. There are 70 years of research showing definitely excessive thermal effects can be dangerous. And for international exposure guidelines and the assessment standards, they are over there and they evolve over years to protect the population, for general publication, public. A larger numbers of the expert reviews and have concluded that no adverse effect have been confirmed below the current international exposure limits, such as ICNIRP or IEEE. And if the ordinary exposures for the cell phone or the base stations are very low. So unnecessary worries can cause so-called a nocebo effect. That means if you believe something can hurt you, it can hurt you. I think that's a very big public health concern from this nocebo effect. So the next one is about the effects. You might hope, we talk next one, next. Yeah. So hopefully, if scientists can discuss EMF safety issues based on validated scientific facts and not have concentrated on the B to F papers on the unreproducible possible effects and opinions, I think we will have less controversy and we have will minimize any concerns in this field. So my conclusion slide is what my the greatest teacher in China 2,500 years ago. He said, knowing what you know and what you don't know, that is knowledge. So if you don't know, don't say you know. So that's what from the expert teacher tell me. So I have been learning from him, and I stick to that. Something I don't know, I say I don't know. Thank you very much for your time and listening. Sorry for the interruption. I don't know what happened. Yeah. Thank you. Hey, Joe, back to you.
Thank you, Dr. Chow. You did an outstanding job with even with challenging technical issues, but we worked through it, and we're going to open it up to a question and answer session. We appreciate everybody willing to stick around. We'll do it for 10 minutes. If staff have other questions, we can do it. I'm going to scroll through here. Robin, I don't know if you have any questions, but we'll get to some questions shortly here, Dr. Chow.
Okay.
So this is Robin. We have a question in the chat. Dr. Chow, you discussed the potential thermal effects of RF exposure. Is there any evidence for non-thermal effects of non-ionizing radiation, such as the excitation of electrons or inhibiting cellular function by interfering with the arrangement of macromolecules, protein, hold on, sorry. Yeah. With the arrangement of macromolecules, protein interactions, or the phospholipid organization of cell membranes?
Well, they are, like in our IEEE database, there are about 8,000 papers. And definitely there are all kinds of effects of reporting so-called low-level effects. We don't like to call it a non-thermal effect because any RF can cause energy into the tissue, can be even very, very small, such as I used for the auditory hearing effect, and a very, very small energy, very, like a millions of degree temperature rise, but the basics is still a thermal effects in there. So we use the IEEE, we use the low-level effects instead of non-thermal effects. So in terms of the many of the reported studies, yes, there are many reports. The question is, are they repeatable effects? And that's the trouble with many of the studies are not repeatable. Not even many of them, not even by their own labs. So that's the problem. And even if there's any confirmed effects, and the problem is we need to show, are they really having any health effects, can cause health issues. And that's why we as a safety standard group, we need to continue to monitor that. So within over the years, we always continue to look at all the possible effects, looking at their quality of the studies, and do they have enough evidence to show, or strong evidence to show for replication or all that. This is a continuing effort from all over the world, how to come up with solid evidence. Can we show anything? And we need to be really concerned. But so what the question was asking, are there other, different chemical reactions or whatever, but cellular level? Yes, there are all kinds of reports on that. But it's nothing to do with electron excitation and all that. We all know from physics, if you don't have an photon electron more than 10 electron volt, you cannot knock out the electrons. So that's called ionizing radiation. You need a very high frequency above UV light in order to do that for the molecules. And in terms of DNA damage, there were reports about that saying because DNA use the nucleic assay can show their DNA damages and all that. But that's still very controversial. Still, some people reported that, and some other people cannot repeat that. If it's really true, we should see all kinds of cancer in the exposed animals in all the long-term animal studies, including the NTP study. But you see only a few the statistical numbers various. Even the animals live much longer. You expect the more survived animals can have more cancers compared to the short life the smaller numbers of control animals. So that can be explained. But so it's still something need to be explored more, and so they'll continue research here. Looking at this possible thing. We continue to see whether it's really true. We want to make sure we are not overseeing something.
Thanks, Dr. Chow. Robin, sorry, I had an audience member that wanted to ask him a question. Go ahead, Lloyd.
Sure. Yes, Dr. Chow, this is Dr. Lloyd Gordon from the Los Alamos National Laboratory. I've been working in this field for 40 years, and I'm extremely familiar with C95.1. This is absolutely the best presentation I've seen in my career. So where I want to go. I am involved in the establishment of electrical safety standards in this country in both IEEE and NFPA, and many of the audience out there also oversee electrical safety. It's very little known that 5 pages in C95.1, section 4.4, deals with shock and induced shock currents, and there are no standards in this US for that, 0. The IEC 6479 is far ahead of the US in this area. So what I've done, Dr. Chow, is I have submitted a proposal for the 2024 70E to put these new standards in the 2019 C95.1 into our 70E electrical safety for the workplace. And I've written a paper on this. So I'm promoting that your work is now put into our electrical safety standard, which it is not. Do you think that's a good idea? I would like to work with you on that.
Okay, Dr. Gordon, yeah, really appreciate your comment, and I really also welcome your contribution to our ISIS committee. Now, this is what we are here for, is to include whatever, people have experts all over the world, and here we have right in US, we will definitely welcome your input. Here we are talking about, it's not really the electrical safety in terms of from the touching the wires and all that. And in this field, it's more like the induced fields from the field, from electrical field or magnetic field, not the touching the current. We have a touch contact is all from the induced current to the conducting object like a metal frame or touching a car or bus, things like that. And in terms of the low frequency, we actually are starting our next revision. Concentrating on the lower frequencies from 0 hertz all the way to 100 gigahertz in terms in this electrostimulation area. So we'll definitely welcome your input to our meeting. Can you maybe after the meeting, you can send me your email. I can have more personal contact with you on this area. For this low frequency, we have Pat Riley. He's a kind of expert on electrical shocks. He's giving a lot of input to this, but definitely we will welcome you. Have 40 years experience in this. We definitely would like to see you help us on this in this area if you willing to participate and help us on this.
Real quickly, I totally understand your expertise is an exposure to the fields. My expertise is an exposure to the shock currents. So that's where I want to complement your work, and we should work together because we need to improve our U.S. standards. Absolutely. Thank you.
Sure. Please contact me. We can put you in the loop. Yeah, thank you.
Okay. I think we have another question. Let's see here. Dr. Chow, is there any insight into the Havana syndrome and drone killer electromagnetic pulse devices?
Yes, I have actually, I didn't send to you. Dr. Ken Foster from University of Pennsylvania and we wrote an article published in the Science-Based Medicine a few months ago and talking about this Havana syndrome. And because there are other reports saying possibly this Havana syndrome is due to this hearing these microwave pulses. And because both Dr. Foster and we have worked on this microwave hearing effects in the past, and we both think there's nothing to do with that. And because it's a very different hearing characteristics, if it is due to the microwave hearing, and the sound should be very, very small. Because like we did our study at University of Washington, at the beginning, we had a hard time hearing it until we called this Mr. Alan Fry. He reported that people can hear microwave pulses and asked him, how can you hear it? We could not hear it. And he said, oh, you have to be in a very, very quiet environment to hear it. So one morning on Saturday, we went to the lab to turn off the huge Honeywell computer, and we went to the shooting room. And by God, we finally we were able to hear it, and in the middle of our head. and no matter how you turn your head, it's always in the middle of your head. You cannot locate which direction it's coming from. So that's the basic characteristics of hearing microwave pulses. And here you're talking about Havana syndrome. They hear loud noise come from a direction, and that definitely is not a microwave hearing sensation. So that's why we had that paper in science-based medicine. I would think there are maybe other reasons, but we don't know what it is because we don't have enough information from the CIA or the Department of State. And when you don't have enough information, you're kind of moving in the dark. You don't know what you are getting, and so we don't know the whole picture, and we cannot speculate what really what's the reason for this syndrome.
Excellent. Thank you, Dr. Chow. Really good discussion. I know we'll probably go maybe another minute or two here. I think this is just a comment from one of the audience members. They had just said that the MW hearing ability sounds pretty cool. So I guess that's a nice compliment to the material.
All right.
Anyway. Just so everybody knows, my colleague Robin Keeler had posted a link actually about what is Havana syndrome actually in the chat. So if you're interested to read more about that, that information is there. So, it looks like we got another comment in here for the chat. Thank you to Dr. Chow. So very knowledgeable. I appreciate him sharing his expert insight. Excellent presentation. So. Anyway.
Thank you very much. Thank you.
Sure. Dr. Chow, I was going to say, would you, I know I've had a number of people ask, would you be willing to share, or is your contact information in the slides? Like, would you be willing to share that with the audience if they were willing to contact?
Yes. Yeah, that's the reason I put my email address at the end. If any have any further questions or something, you didn't think of it today, and you're welcome to write to me. I'll be very happy to help my government staff and colleagues to solve your concerns or your questions. Yeah, definitely.
Excellent. Okay, what I'll do then is I'll put it in the chat just so everybody has his email address and ck.chow@ieee.org. So anyway, all right, folks. Well, it looks like we're probably coming to an end here, so we'll go ahead and conclude. Dr. Chow, thank you again so much for your time. Let me stop the recording and